Okay, way number 22 deals with atoms and their charges. All atoms, you can assume, are electrically neutral, which means that all the charges within an atom add up to zero. So all the numbers of positive protons equals the numbers of negative electrons. So if you look on the periodic table, at carbon, for example, to look at the number of protons, we look at the atomic number. It has an atomic number of 6. Because this is an element that's neutral, the number of electrons also equals 6. And you can tell by the electron configuration that this sums up to 6. So it has 6 protons, 6 electrons. Therefore, it's a neutral atom. If it is not neutral, meaning that it has a charge, it means that the number of electrons have changed and we formed either a positive ion or a negative ion, depending on whether the protons outweigh the number of electrons. So let's try some problems that deal with this. What is the number of electrons in an atom of scandium? So you'll need to use the periodic table for a lot of these problems in order to determine how many electrons or protons are present within an atom. Okay, an atom of scandium has an atomic number of 21. Therefore, the number of electrons should also be equal to 21. So the answer is 1. An atom in the ground state has 2 electrons in its first shell, 6 electrons in its second shell. What is the total number of protons in the nucleus of this atom? Again, you can assume that this atom is neutral, unless otherwise stated. Because it has 2 electrons in its first and 6 in its second, it has a total of 8 electrons. So for it to be neutral, it also must have 8 electrons. 8 protons. In this case, this atom is oxygen. And we know that it's oxygen because it's the only element with an atomic number of 8. A neutral atom of an isotope of element X has 44 electrons and 63 neutrons. What is the mass number of this isotope? So this requires use of this problem as well as previous ideas regarding the mass of this element. Okay, to find the mass, we need to know which subatomic particles contribute mass toward this element. And the only 2 subatomic particles that do that are neutrons with a mass of 1 and protons with a mass of 1. But it doesn't tell you how many protons there are. However, it does tell you that there are 44 electrons. Because it has 44 electrons, it also must have 44 protons because it tells you that the atom is neutral. It has 44 protons and 63 neutrons, and each of those particles has a mass of 1. Therefore, the total mass of this isotope is the last choice, 107. Next problem. What is the total number of protons in an atom with the electron configuration 2-8-18-32-18-1? You can assume that this atom in question is neutral. Therefore, the number of protons should equal the total number of electrons. To find the total number of electrons, we simply have to add up all these numbers, and we get 79. Therefore, the answer 2 is correct. Last problem. What is the total number of electrons in a sulfide 2- ion? So for this, we have to take advantage of this atom no longer being neutral. It is negative. So what does that tell you about the number of electrons versus the number of protons in this sulfur atom? For a sulfur atom to be neutral, the number of electrons and the number of protons both equal to its atomic number, both equal 16. However, it is a negative ion, which tells you that the number of electrons, because they're negative, outnumber the number of protons. So this atom has 16 protons, but actually it has 18 electrons for it to have a -2 charge. Where does that -2 come from? Well, 16 positives plus 18 negatives will give you a -2 charge. So in order for it to have that -2 charge, it has to have 18 electrons. So when figuring out these problems, make sure you assume that the atom in question is neutral, which means that the protons and electrons are equal. This can always be confirmed by the periodic table. If you look up the atomic number and the electron configuration, they both are equal. But if you're talking about an ion in this case, then the number of electrons is unequal to the number of protons. So be careful about problems where they give you ions instead of neutral atoms. Hopefully this was helpful. Thank you for watching.